All right, we're going to study three types of interest formulas. Simple interest, which is normally when you borrow money from your nana or something, it's just a flat fee. There's no compounding the interest rate. And then there's compound interest, and then there is continuous interest. We're going to go ahead and do this quick example for continuous interests. And so here's the problem. How long would it take you to double your investment of $1,000 in a savings account if you were lucky enough to get a 2% interest rate these days, and that's pretty rare, but it's compounded continuously. That word continuously is a calculus term. That means if you compounded the interest every nanosecond. In other words, it's just an infinite number of times of compounding, and compounding is when interest is either activated, paid, earned, whatever you want to call it. But the verb to compound interest is kind of a complicated one. But let's go ahead and do this problem. Remember, the word continuously tells us to use the continuous interest formula. The big A stands for the total amount, also called the future value. What that means is that after the however many years you have invested this money, this will be what the account will be worth. Okay, so that's the future value. P is what we call the principal. That's what you start with. That's your initial investment, also called present value. And E is that funky little irrational number that goes 2.718, blah, 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 blah. It's like pi. And R is the interest rate. And T is the time in years. Okay, time is always in years in these formulas. So let's pull out the information that we need. So we know what P is, we know what R is, and we have to solve for T. Okay, so A, the future value, is going to be $1,000 what we start with. E is still E. R is 2%. Always change your percents into decimals. And T is what we're trying to solve for, and that T is actually a factor. So, but we do know what A is going to be because we're trying to figure out how long it's going to take to double at this rate. So double 1,000 is simply 2,000. Okay, so now we're going to do some algebra. Divide both sides by 1,000. It's going to give us 2 equals E raised to this. How would you undo this, you might say? This is where natural logarithms comes in. Okay, let's get some working room here. But if you have anything with an E as in a base, you know if you take the natural log of it, you can do some algebraic magic. But if you're going to take the natural log of one side of an equation, you always have to take the natural log of the other side of the equation. It's just like adding a -7 to both sides, multiplying both sides by 4, something like that. What you do to one side of the equal sign, you must do to the other side to keep it true. Okay, so we know the rules of logarithms, that if a base has an exponent, we can pull this exponent out as a factor, like that. And the natural log of E, I'm hoping you know by now, is 1. And 1 times anything doesn't change anything. So now we're going to divide both sides by 0.02. So now I have to pull out my calculator because I just can't tell you what the natural log of 2 is off my head anymore. So please hold. So we hit 2 natural log, kabam, and we're going to divide that by 0.02, double kabam. That's your answer. So roughly 34.66 years, which is a long time these days. Your money used to double every 7 years, 7.5 years, but because of the housing fiasco up here, it's just a mess. So, but that's the number of years. I might try to trick you and say, how many months are in 0.66 years? 0.66 is roughly 2/3. There's 12 months in a year, so 2/3 of 12 would be 8 months, but that's how you do these. Hope you enjoyed it. MGZ out.